Hello and welcome to part 2 in the series on the M5 capscrew. In this part we're going to continue where we left off, and I'm going to cut the screw thread on this blank that we created in part 1. So to do that, essentially what I'm going to do is sketch a profile here of a metric thread form, and then use a swept cut feature along a helical path to cut out the thread form on the blank. So on the PDF that you have on the Moodle page here, I've put up an image of the basic metric thread form for ISO metric threads. Now it's essentially the same thread form as you would have on, let's say, the American Unified Thread Series threads. It's based on a 60-degree, an equilateral triangular shape here. Truncated, so the bottom cut off at the root of the thread and the top cut off at the crest of the thread here. It's a triangular thread form. As I said, it's common in metric threads and also in imperial threads. It's 60 degrees. Now there are other thread forms that are similar. So the plumbing thread, the British Standard Pipe thread, is quite similar to this, except it would be a 55 degrees angle rather than 60. The Whitworth thread as well, I think it's 55 degrees, and there's another thread that's used on bicycles that would also be 55, but the ISO metric series is a 60-degree triangle. So we see some of the major dimensions here that you'd need to worry about would be this diameter here. So this is the major diameter of the thread. So from the center of the bolt, in this case, to the very tip of the outside thread, that would be D here, the major diameter. The diameter from the center of the bolt to the root of the thread is DR, D root. I think we called it the minor diameter in the previous video. And DP here is the pitch diameter. That's essentially to the halfway between the top of the triangle and the bottom of the triangle. Here is the pitch diameter. Now there's one other diameter, or one other parameter, that we didn't create the last day, and that's H here. H is the distance from the very bottom of the triangle to the very top of the triangle, the height. And a lot of the other dimensions are based on that value there. So you see that the from the root of the thread up to the crest of the thread is 5/8 H. Across the bottom at the root of the thread here is that's based on the pitch. What else? So what we might do is we might create another parameter, another variable within our model here for H. So if I go back in here, I'm going to create another global variable here for H. So if I call that H and tab across, I can just create a variable here that is a calculated based on some of these other ones here. So to work out that value for H here, what it is, it's the pitch. So we can say equal to our pitch, which we've already created, 0.8, multiplied by the sine of 60. So we can go to functions here, sine of 60, and specify that that's 60 degrees rather than radians, but 60 degrees here. So the pitch multiplied by the sine of 60 degrees, and that should calculate out to 0.693 or thereabouts. And that's that. So we could have actually used that in the previous example. We could have worked out the minor diameter here by taking the major diameter and subtracting 5/8 H off the radius, so double that. If you did twice 5/8 H subtracted away from 5, I believe should give you 4.02. Okay, so we may or may not use that value here, but it's no harm to have it in there. So okay, so what I'm going to do now is I'm going to create the helix that we'll that we'll use to create our path for our swept cut. So to create a helix feature, you go to the Features tab here. Over towards the right hand side you'll see Curves, and if you drop down that menu there you'll see Helix and Spiral. So to create a helix we need to create a sketch on a planar face, and that sketch contains a sketch that contains a single circle. So you could do it on any plane. You could do it, say, on my right plane here if I like, but I'm just going to do it on that flat face. I'm going to create a sketch, spacebar, and look in normal 2, and I'm going to draw a circle, and I want that circle to be the same size as my minor diameter here. So I could dimension it equal to my minor diameter, but what I'm going to do is just control click. So highlight the circle, then control click on this circle, and I'm going to make those equal in diameter. That now is fully defined. I'll close out of that. So that's the only sketch I need for the helix. You'll see it's launched this helix tool here. We have a number of different ways of defining the helix. We can define it by the pitch and the number of turns or the number of revolutions. We can define it by the height and the number of turns or revolutions, or we can define it by the height and the pitch. And that's what I'm going to do, is the height and the pitch. So we know that the pitch of our thread is going to be 0.8, and we know the height in this case would be 10 millimeters, or the length of our finished screw thread. So I want it to be a constant pitch. I want the overall height to be 10 millimeters. Actually, I'll make it a little bit larger. I might do that in just a second. I'll put it in as 10 for now. There's a slight quirk in Solidworks here, that it doesn't allow me to actually put in a calculation here. So I can't just say equals to my global variable for height. So what I'll do for now is I'll just put that in as a value of 10, and we'll change that afterwards to include a calculation based on my global variable for the height, or the length rather, of the screw thread. The pitch here, that will be our 0.8, and again I will change that to make that a calculated value in a moment. For now I'm just going to put that in as 0.8. The start angle refers to whereabouts on that circle does the helix start. I don't believe that makes a huge amount of difference in this case, but I'm going to set it to 90 degrees, which should be the top of the circle here. So if I set that to 90, you'll see that the helix is just starting at the top of the thread here. And I want to swap the direction of that. Reverse direction here, so that it's running that direction. Okay, and that is the path of that's the path that we're going to use to cut out that screw thread in just a moment. Now, you saw that within that helix and spiral feature tool, I couldn't put in my global variables. And as I said, those variables are optional. You don't have to do that for this exercise, but I'm going to do it. So I couldn't put in the global variables there, but if I click on that preview of the helix there, you'll see I have those dimensions, my 0.8 and my 10. Now if I double click on that 10 millimeter dimension there, I can at this stage change that to be based on a global variable. So I'm going to let that equal to my global variable, my length 10, and if I highlight that again, this 0.8 here, that's the pitch of the helix. If I double click there, I'm going to let that equal to the pitch of my screw thread P. Okay, so now if I change these variables, the pitch of the helix or the length of the helix should change if I change either of these global variables. Okay, so that's the helix created. The next thing I want now is to create a sketch of the profile that we're going to cut away from this blank here. So I'll create a new sketch, and I'll create it on, say, the front plane again here. I'll look straight in at the front plane. So I'm going to create a sketch up here on the front plane. Roughly speaking, it's going to be the shape of a truncated equilateral triangle, so 60 degrees. But the basic shape will be down, across, back up, and make a triangle out of it. Now we can fix this in a moment, so I'm going to say first of all make this line here horizontal. I will dimension this to be 60 degrees here. I'll dimension this to be 60 degrees as well. And that's going to be the basic shape that we're going to cut out from the part. Now we'll just have a look at that PDF again for a moment. So you'll see here this 60 degrees, 60 degrees. The dimension on the flat at the bottom of that truncated triangle, that's based on the pitch of the thread, so it's a quarter of the pitch. So for our 0.8 millimeter pitch, you wind up with a flat of 0.2 at the bottom, and then there's a radius on that as well, which is half of that value, so 0.1, so that'd be 1/8 of the pitch. Okay, and then the overall height of the triangle, that would be, we can just check that out, the overall height of that would be 5/8 h, so we can put in that value there. In fact, that, as long as that's higher than the top of the thread, it shouldn't really matter, so I might just put that in as a let that equal to h, for example. So this dimension here on the flats, this is 0.2, but what that 0.2 is based on is it's equal to the pitch of the screw thread divided by 4, and that should calculate out to 0.2 then. Okay. The overall height, as I said, then the height of this triangle, it doesn't particularly matter, as I said, as long as it's greater than the major diameter here, then we should be okay for creating the thread form. I will put a dimension on it though. I'll say from here to here, we'll let that equal to, if we let that equal to this h value here. Okay, and we're nearly there. We need to put a fillet radius on these corners here. Now to do that, I'm going to use the sketch fillet feature. Okay, so the sketch fillet feature, we'll set that value there. I don't know if I can, yeah, I can't create an equation in this one here, so I'm just going to let that fillet radius equal to 0.1, and I'm going to fillet those two corners there. Excuse me, I'll do that again. So sketch fillet, set the sketch fillet equal to 0.1, and then those two lines, and also these two lines here. So that will round off those two corners. Now, if I wanted to, I could come in and put an equation here on this. Oops. I could put an equation on this here to let those equal to 1/8 of the pitch. Okay, so that's the profile created. Now it's still not fully defined because at the moment it's still free to move over and back like this. So what I'll do, it won't really functionally affect the shape of the screw thread where this goes, but what I'll do is I'll just anchor this point here to be directly above the start of the screw thread here. So I'll highlight those 2 points and make those coincident. So that's making this point at the end of that radius there, it's making it coincident with the plane, the circular plane there of this circle. Okay, and that now is all fully defined. I'll accept that change, and that's my sketch now for cutting the screw thread. So the last thing I want to do then is to create my swept cut feature. So we've got the features here, swept cut. Now the swept cut is basically the same as the extruded cut feature, but rather than extruding a cut in a straight line, it's going to extrude it along a curved path, and that curved path will be our helix that we've created already. So I'm going to take this sketch, sketch 3, I'm going to create a swept cut feature, and you see my options here. The profile is going to be our sketch, sketch 3. The path then is going to be that helix that we've created. So if I click on that helix, now I get the option here, what direction do I want to extrude that cut in. So direction 1 would be, I believe, to the left in this case, bidirectional, or just in direction 2. So I'm going to go just in direction 2, down this way, and click OK. And you'll see then that has taken that profile and it has extruded along the helical path to give me the overall finished thread form. Okay, and I think that is all. It's all correct. I didn't check the direction of my helix, whether I had it making a right hand thread or a left hand thread, but I think that looks like a right hand thread, so I think we're okay. Okay, so I'll finish the video at that, and then I'll come back with, in part 3, we'll model the head of the screw. Okay, thanks for watching.